Hello students, today I would like to discuss the next model in cones. So coming to the problem, find the vertex of the cone, find the vertex of the cone 7x square plus 2y square plus 2z square minus 10xz plus 10xy plus 26x minus 2y plus 2z minus 17 is equal to 0. 7x square plus 2y square plus 2z square minus 10xz plus 10xy plus 26x minus 2y plus 2z minus 17 is equal to 0. Right. So coming to the solution, so here we have to find the vertex of the cone. Okay. So for this, we have to consider the homogeneous equation. So consider the homogeneous equation, that is f of x comma y comma z comma t. So we have to introduce t also. So for that, what we have to do is 7x square plus 2y square plus 2z square. So minus 10xz plus 10xy plus 26xt. So because the equation should be homogeneous. Homogeneous means for each and every term the degree should be same. Here the first term the degree is 2, second also the degree is 2, third, fourth, fifth, up to fifth term the degree is 2. Whereas coming to the sixth term we are having the degree 1. So wherever the terms we are having degree 1, so there we have to introduce a variable t. So that I have written 26xt. After that, minus 2yt plus 2zt. And finally constant. For constant also you have to introduce t square. So each and every term should be of degree 2. So that we have to consider this homogeneous equation for the given equation. Okay. So after that we have to find the partial derivatives with respect to x, y and z. So first I am finding with respect to x. So f by x. So with respect to x, we get the 14x minus 10z plus 10y plus 26p. Okay. So since we are having 4 x terms, the first term that is 7x square. So the derivative for x square is 2x. So 2x into 7 is 14x. So next minus 10xz. Minus 10z is constant. The derivative for x is 1. So that we get minus 10z. Next plus 10xy. Here also 10y is constant. The derivative for x is 1. So that we get 10y plus 26t. Okay. So this is the value of dou f by dou x. So coming to dou f by dou y. So with respect to y, so we have to find the derivative for y terms only. So because remaining all terms are constants. So 2y square, the derivative for 2y square is 4y. And we are having y term 10xy, that is for the derivative for 10xy with respect to y is 10x. And one more term we are having, that is minus 2yt. And the derivative for that term is 2t. The derivative for y is 1, so that we get minus 2t. Okay. After that, we have to find dou f by dou z also. This is equal to, so now with respect to z, we get 4z minus 10x and plus 2t. So just we are having three terms, three z terms, so that we have to find derivative for those terms only. Remaining all other terms are constants. Okay. And finally, we have also find the derivative with respect to t also. Dou f by dou t. So coming to the t, we get the 26x minus 2y plus 2z minus 34t. T square derivative 2t, so that we get minus 34t. So in this way, first we have to find the partial derivatives with respect to x, y, z, and t. Okay. After that, what we have to do is, now we have to consider at t is equal to 1, consider dou f by dou x is equal to 0, dou f by dou y is equal to 0, dou f by dou z is equal to 0, and dou f by dou t also is equal to 0. So the next what we have to do is, we have to put t is equal to 1 in the partial derivatives, and we have to equate those partial derivatives to 0. Okay, so that I am writing, so in place of t, 1 in partial derivatives, so that we get uh, dou f by dou x is equal to 0 implies we get 14x minus 10z plus 10y plus 26 plus 26 is equal to 0. If you write that 26 to the right side, we get minus 26. Okay, we have to put t is equal to 1, and we have to equate dou f by dou x is equal to 0, so that we get this equation. Okay. After that, so treat this as 1. Now dou f by dou y is equal to 0 implies we get 10x plus 4y minus 2. So in place of t, we have to put 1, so that we get minus 2. And if we write that minus 2 to RHS, we get is equal to 2. Treat this as equation 2. Okay. So coming to dou f by dou z is equal to 0. This implies minus 10x plus 4z plus 2. And if you write that plus 2 to the RHS, we get minus 2. Treat this as equation number 3. What we are doing is, we have to put t is equal to 1 in the partial derivatives, and we have to equate those is equal to 0. Okay, right. After that, dou f by dou t is also equal to 0. This implies, so in this equation also, we have to put t is equal to 1. So 26x minus 2y plus 2z is equal to 34. So this is 4th equation. So finally, we get 4 equations in x, y, z. So now we have to solve those equations to find the x, y, z, and that point is nothing but the vertex of the given cone. Okay. So now we have to solve these equations to find the values of x, y, z. So now I am going to solve 1 and 4. From 1 and 4, I am going to solve equation 1 and equation 4, so that I am multiplying equation 1 with 1, so that we get 14x minus 10z plus 10y is equal to minus 26, and I am multiplying 4 with 5. This implies 26 5 is 130x, 5 2's minus 10y, and 5 2's 10z is equal to 150 20 170. Okay, so we have to add these two equations, so that, so plus 10y minus 10y gets cancelled, and plus 10z minus 10z gets cancelled. Okay, by adding these two equations, so we get 144x is equal to 170 minus 26 will give us 144 once again. So this implies we get x is equal to 1. So we have found the value of x from 1 and 4. So whenever we get x, so from equation 2, now we can find y value. Okay, so I am writing here So from equation 2, so 10x plus 4y is equal to 2 we are having. So here we have to put in place of x1 so that we get 10 plus 4y is equal to 2. So 4y is equal to minus 8. So that y is equal to minus 2. So we get y value also. And finally, if you want to find the z value, so you can substitute into third equation. From 3, we can find z. So from third equation, minus 10x plus 4z is equal to minus 2. So minus 10 into x is 1 plus 4z is equal to 2. So 4z is equal to 2 plus 10 is equal to 12. So that we get z is equal to 3. 12 by 4 is 3. So I have found all the values of x, y, and z. So therefore, we can write x comma y comma z is equal to 1 comma minus 2 comma 3 is the vertex of the code. Okay. So if you want to verify is this the correct one or not, so we have to substitute this particular value in the fourth equation. So in the fourth equation, we are having that sorry, while finding z value, so we are having minus 10x plus 4z is equal to minus 2. So from this, we are writing minus 10 into 1, minus 10 plus 4z is equal to minus 2. So that we can write 4z is equal to minus 2 plus 10. So that we get 8. So 4z is equal to 8 implies we get z is equal to 2. So, so the vertex is 1 comma minus 2 comma 2 is the vertex of the code. If you want to verify whether this one is the correct one or not, we have to substitute this particular point in the fourth equation. Okay. So from 4, I'm going to substitute this value in fourth equation. So from 4, so what is the equation we are having? 26x minus 2y plus 2z is equal to, so 26 into x is 1 minus 2 into y is minus 2 plus 2 into z is 2. So that we get 26 plus 4 plus 4, which is equal to 34. It means I get 26x minus 2y plus 2z is equal to 34. Yes, that is the correct answer. It means, so this is the vertex of the code. Okay, once again, so this is very, very important model. Okay, so how can we find the vertex for the given code equation? So first of all, after giving the equation, we have to consider the homogeneous equation. So here the homogeneous equation is nothing but we have to make all the terms to the same degree. Okay, up to some terms we are having here the same degree, that is 2. So whereas coming to the sixth term onwards, we are not having degree 2. So that we have to introduce a new variable t. Okay, by writing 1. By writing 1 is equal to t. By writing 1 is equal to t, we can introduce the variable t. So that I have written here 26xt minus 2yt plus 2zt, and in place of constant we have to write 1 square, that is t square. Okay, so that we have introduced t, that is a homogeneous equation. After writing homogeneous equation, next we have to find the partial derivatives, all the 4 partial derivatives with respect to x, y, z, and t. So after finding the partial derivatives, in partial derivatives, we have to put t is equal to 1 and equate them to 0. Okay, so then we get 4 equations, and you have to solve those equations in your way to find the values of x, y, z. And that point x, y, z is the vertex of the given code equation. If you want to verify whether that is a correct one or not, you have to substitute that in the any one of the equation we are having from the 4 equations. If it satisfies, then you say that that particular vertex is a correct solution. Okay. In this way, we can find the vertex of the cone. Okay. Right. I have given you three more problems. So while coming to the second problem, here it was asking that so that the equation represents a cone with vertex. So whereas in problem 1, 3, and 4, it was directly asking that find the vertex. So if you want to show that this particular equation represents a cone also, first of all, we have to find the vertex. Here the vertex was already given here, but we have to find the vertex by the above problem. Okay, by using the method how we find the vertex in the above problem. So first of all, we have to find the vertex. After finding the vertex, here we have verified that whether the vertex is the correct one or not by substituting the vertex in any one of the equations we are having from the four equations. So whenever we have substituted the vertex in this particular equation, if it satisfies, so then we say that that equation represents a cone. Okay, so this is an indirect question. So for this problem also, we have to uh, solve this problem in the above way only. Okay, and these third and fourth problems are very direct problems. We have to find the vertex only, so that we have to solve these two problems. So that are three problems. Okay, thank you.